I'm a mild-mannered physics professor at the University of Minnesota. I created a class that was originally called Everything I Know About Science I Learned from Reading Comic Books. And in this class, we covered everything from Isaac Newton to the transistor, but there wasn't an inclined plane or pulley in sight. All the examples came from superhero comic books, and as much as possible, those cases where the superheroes got their physics right. The National Academy of Sciences and Engineering will matchmake scientists to Hollywood. And so I received a call from this woman at the National Academies, and she asked me, have you ever heard of this comic book called Watchmen? And then we spoke with Zack Snyder, and they said, yeah, why don't you come on up, and we'd like to talk to you.
So yeah, did you look around? I have stuff in here.
I know. And
some stuff they don't have, probably.
I just felt like a physical movie because it was, different sort of graphic sensibility. It seemed like a different approach was needed, and I think that's what sort of led to us doing stuff like this.
All right, well, good. So at 5, you're gonna do the, at 5?
I think at 5:30.
Okay, perfect.
You know, as physicists, we go to a lot of strange places, do a lot of strange things, and this has been a truly unique and fun and exciting experience, and I want to thank everyone. So, as punishment, I'm going to give you a physics talk. Well, I gave my lecture to the crew, but I also brought some PowerPoint slides of labs and classrooms. And then I also have some things of some representative data.
So that's from the 80s, that first one?
That's right.
Oh, it looks like something from the 50s.
I know. You could use it for the 50s.
That's what I would think.
They were very interested. Alex McDowell was very interested in knowing what would a lab look like in 1959? What does a physics lab look like in 1985?
And then we wanted to reconvene in about half an hour to talk specifically about Manhattan's lab and Guyler Flats.
Here we see Dr. Manhattan working on some device early on in the story. What's he doing? What would he be working on?
We're just, asking the question, what's John Osterman doing?
Right.
We'll get into this later.
Is it reasonable that an intrinsic field removal chamber would look the way that it does? Alex McDowell put it, and this has always struck me, he said, we want to know what's around the corner of a long corridor, even if the audience doesn't go down that hallway.
You can get a bit of that to keep,
right.
The physicists of the world happy.
Both of them.
Which after all.
Everybody stay calm. We'll try to keep this brief.
Clearly, people can't fly, walk through walls, run at super speed. And I don't see my job as a physics professor to just be like Professor Grump or Dr. No and say, this could never happen and this is impossible. What we do in the class is we grant each character a one-time miracle exemption from the laws of nature and say, well, if you were super strong or could stretch like a rubber band, could you run across the ocean or up the side of a building, catch bullets in midair? All things this character is shown doing, all things that are correct from a physics point of view. So you can use comic books to illustrate physics principles.
You with me? Yeah.
In Watchmen, I would say the miracle exemption is Dr. Manhattan, and basically it appears that in essence he has control of his quantum mechanical wave function. That's the notion of a miracle exemption. The intrinsic field is described by Wally Weaver in the graphic novel as everything except gravity that holds us together. If you take everything without gravity, you have electromagnetic forces, you have the strong force that holds nuclei together, you have the weak force that enables certain nuclei to decay. Those are the three components that hold atoms together. But if you could remove electromagnetic forces, there would be no reason for atoms to stick together, so all molecules would fall apart. You would be disintegrated at the most basic subatomic level. Through a miracle exemption, John Osterman is somehow able to reassemble himself. It wasn't until 1925 that Schrodinger and separately Heisenberg kind of figured out what's called modern quantum theory, which is then the foundation of everything else. Scientists that were just basically trying things to see what happened discovered fission by shooting neutrons at uranium And with the realization that the release of energy could lead to the development of an atomic weapon, quantum mechanics then suddenly got one of its first large-scale applications in the Manhattan Project. Back in the start of World War II, when scientists realized that it was possible that an atomic weapon could be developed, the United States put in a crash program to develop an atomic weapon. And scientists were, in essence, drafted into the Army. And some of the smartest people, the largest collection of Nobel laureates probably ever put together, all lived together at an Army base, worked together, and figured out how to construct and actually built the first atomic bomb. Now, all objects have a wave associated with them. We don't notice this because the larger the momentum, the smaller the wavelength. But if Doc Manhattan is able to vary his wave at will, he can do all sorts of things like stretch his wave out to some other distant location, and then he can materialize at that location. He calls it teleportation. In quantum mechanics, we call it quantum mechanical tunneling, and it goes on all the time. He can change his size at will. It's certainly not implausible if you could control your wave function that you could change your size. He has the ability to extend his wave function and presumably change some of the binding forces inside someone else's atoms. And if you mess with those binding forces, the atoms fly apart and the person explodes. This is, again, something that's in the graphic novel that is fairly realistic. The students and scientists sometimes are under a lot of pressure. And sometimes that pressure and that anxiety leads to depression. And one thing that I've noticed being an advisor to various students is you see them throw themselves into their research and throw themselves into their work because it's the one aspect of their lives that they feel they understand.
I think he goes from antipathy to apathy, where he just can't care anymore.
My red world here, now, means more to me than your blue one.
He has a vision of the world that no longer includes humans for a while.
The existence of life is a highly overrated phenomenon.
When an electron moves at a very high speed, it can actually induce a blue glow. This phenomena is called Cherenkov radiation. The speed of light is the fastest velocity in the universe in the vacuum of empty space. But light actually can travel slower than that speed when it passes through water, say, or passes through glass. And this is the source of the familiar, like, mirage effects, where if you put a pencil in a glass of water, when you look at the pencil in the water and in the air, it looks broken. And what you're seeing there is a refraction effect, an optical illusion by the refraction that at its heart results from the fact that the speed of light in water is about 3/4 what it is in air. If I send an electron at a speed greater than 3/4 the speed of light through water, it's actually now traveling faster than light can travel. What it does then is it sets up, in essence, an electromagnetic sonic boom. A little shock front is created where it sheds electromagnetic energy in the ultraviolet and blue portions of the spectrum. And what you're seeing there is the Cherenkov radiation from high-speed electrons that are coming out of these nuclei as they decay. Dr. Manhattan is constantly having to kind of hold himself together. And so there's always electrons that are leaking out, but those electrons that are leaking off give off a blue glow. And by changing the velocity of the electrons, he can change how blue he appears.
We don't have time for makeup. That blue is too light for television.
Is that dark enough?
The same blue glow from Dr. Manhattan is the blue glow that you see from nuclear isotopes that decay. Not every nuclear isotope emits a high-energy electron, but some that do are, say, strontium-90. If you had access to strontium-90 and you put it in people's food or milk or cigarettes or things like that, it would get incorporated, they would get cancer. So if you were trying to frame some guy, tying it up to these high-speed electrons, these beta decay, would be a characteristic signature that would lead back to Dr. Manhattan.
You're suggesting I was the cause.
I would have to say about at least 80% of the stuff he does is legitimate, as far as the one-time miracle exemption of having control of his quantum mechanical wave function.
I can change almost anything, but I can't change human nature.
Archie.
Oh, well, short for Archimedes. Marlin's pet owl. Stupid nickname.
This is the chipboard owl ship.
Yes. This one could never fly.
Never. This is the actual ship. Yeah. This is how big it is. This is where they drive it from. This is how big it is inside.
It could really fly, but his miracle exemption then is the power supply.
Let's go.
The movie at least shows these jets that are shooting out and enabling the ship to hover and enabling it to fly. If I want to take an object that weighs about the size of Archimedes and lift it up over rooftops in Manhattan, I need a power, the rate of energy usage of about 4.4 megawatts just to do that and to keep that up in the air. If I were to fly from New York to Antarctica because I want to visit one of my colleagues that I think has gone rogue, I can do that, but it would use up the equivalent of just a little under 5,000 gallons of gasoline. It doesn't look like there's any place on that ship where you can store 5,000 gallons of gasoline. That's the part that requires a suspension of disbelief.
It's weird. In the Millennium Falcon, don't they push the floor?
Yeah, they do. But that's fine. They're.
You want to do
That's
a nod
fake.
to that? Or you
Yeah, I see far, far away.
That's fake.
Wow, these rock.
They amplify the spectral range.
It might have been a little bit science fiction-y in 1985, but by 2005, very routine. And again, quantum mechanics.
You can see me, right?
I can see everything.
Night Owl, again, a little bit ahead of the curve in 1985. Kind of boring by now, because eventually we all catch up. But that exactly requires no suspension of disbelief, no miracle exemption. A bullet leaves a gun at a velocity roughly the speed of sound or so. That crack you hear from a rifle shot is actually a little sonic boom as the bullet passes overhead and is moving faster than the speed of sound. To stop that projectile that's going, say, 600, 700 miles per hour in a short time, even if he kind of, you know, lets it recoil a bit in his body and things, I doubt I could see how he's able to do that. But there again, that's one of those cases where even he wasn't sure it was going to work.
Tell me, what do you see?
Rorschach's mask, it appears to consist of two immiscible fluids like oil and water that are buoyancy matched, such like in a lava lamp. So you have these two fluids, they don't mix, they don't wet each other, so they stay phase separated. And they're roughly buoyancy matched, so slight changes in his facial heat, you know, perspiration, or if he gets flush, will warm up slightly the mask and change and induce, like in a lava lamp, induce the patterns to change. Though I would have to say that the particular patterns don't necessarily reflect his emotional state, they just are random patterns. There might be some phrase for people looking at a random pattern of black and white splotches and somehow inducing psychological meaning out of it, but I don't know what you would call that. Well, certainly these grappling guns exist. A lot of it is just a question of conservation of energy. You are going to shoot a projectile and you want it to leave your gun with enough velocity that it can go up 40 stories. That's pretty high, and that requires an initial muzzle velocity of about 200 feet per second, about 140 miles an hour. Well, guns shoot off their projectiles at 700 miles per hour or higher, but they're dealing with much smaller masses. So if you want to have the mass of that actual hook go up there at such a large speed, that's going to take a lot of energy. It's going to have a little bit more than just a little puff of air that's going to do it. But again, it's the kind of thing that is slightly unphysical, but not egregiously so. So, and you know, I'm not going to tell Rorschach he can't do it.
Keep your own secrets.
Even though I'm a physics professor, when I go to these movies, when I read these comic books, I don't sit there with a pad of paper and a calculator. And that's the kind of structure almost you could also see that Manhattan being very attuned to. You know, he wants his symbol to be a hydrogen atom, but a hydrogen atom does not look like, you know, the atoms don't look like this that he says. It's something more like a proton and an electron. There was a lot of things where they didn't really truly need me, because if I were to tell them that such and such a thing was physically impossible or was physically wrong, but it was what was in the graphic novel, they were going to go with the graphic novel. Because I think they were more concerned about upsetting the legions and legions of Watchmen fans rather than upsetting a physics professor from Minnesota.